Hello and welcome everyone to the AI Research Roundup. I'm your host Alex, and today we're diving into some interesting work in generative models. We'll be looking at a paper titled CFG-Zero Improved Classifier-Free Guidance for Flow Matching Models. So, the researchers looked at Classifier-Free Guidance, or CFG, a common technique used in diffusion and flow models. They found that early in training, standard CFG can actually steer generations the wrong way. Their solution, CFG-Zero, involves optimizing a scaling factor and zeroing out the initial steps of the generation process. They show this really helps guide these flow matching models more effectively. Right. And speaking of implementing these techniques, what we're looking at here is actually the official GitHub repository for CFG-Zero. The authors have made their code public, which is always fantastic to see. So if you want to dive deeper into the implementation details, or maybe try out CFG-Zero with your own flow matching models, the resources are available right there. It really helps with reproducibility and lets the community build on this work. Okay, so speaking of seeing the results, let's look at Figure 1 here. This gives a really nice visual comparison. The prompt was for a dense winter forest scene with a fox leaving paw prints, generated using SD 3.5. On the left, we see the result using standard CFG. And on the right, the result using the proposed CFG-Zero method. You can see, especially in the zoomed-in sections, the image generated with CFG-Zero appears clearer, maybe a bit sharper, especially looking at the fox itself. It's a good example of how this technique can improve the final image quality. Okay, building on that visual comparison, Figure 2 here shows us something slightly different. Instead of comparing CFG-Zero to standard CFG, this one compares standard CFG on the right to just the conditional generation on the left. The prompt this time was for a mysterious underwater city. You can see the conditional image on the left is, well, a bit less defined maybe, whereas the standard CFG image on the right seems to better capture the prompt, showing clearer structures like the towering glass domes and the bioluminescent corals. This really highlights why CFG is used in the first place, to improve that alignment and quality. Okay, now Figure 4 expands on those visual comparisons we saw earlier. Instead of just one example, this figure gives us a whole gallery, showing results from different models, like Lumina Next, South Dakota 3, and SD 3.5, across a variety of prompts. Similar to Figure 1, it directly compares standard CFG, shown in the orange boxes, against the proposed CFG-Zero method in the green boxes. And generally, looking across these different examples, the images generated using CFG-Zero seem to show richer details, sharper textures, and maybe fewer artifacts, suggesting the benefit holds up across different models and creative prompts. Okay. So, beyond just looking at the images ourselves, Figure 5 here gives us results from a user study where people were asked to compare the outputs. Again, it's comparing the proposed CFG-Zero method, shown in the teal bars, against standard CFG in orange across those same models, Lumina, South Dakota 3, SD 3.5, and Flux. People rated them based on overall quality, detail, color, and text alignment. And you can see pretty clearly, users consistently preferred the images generated with CFG-Zero, often by quite a large margin, especially for detail and color fidelity on models like SD 3.5. Going beyond still images and user preferences, Figure 6 here extends the comparison into the realm of video generation. We're looking at results from a model called WAN 2.1, comparing standard CFG on the top row for each prompt against the proposed CFG-Zero method, labeled hours, on the bottom row. You can see for prompts like a bicycle in snow or an astronaut, the videos generated using CFG-Zero appear more coherent and perhaps more plausible, showing the benefits seem to carry over from images to video sequences. And going further with those video results, Figure A3 here just gives us even more examples. Similar to what we saw in Figure 6, it's comparing standard CFG on top versus the CFG-Zero method, again labeled hours, on the bottom, using that same WAN 2.1 video model. But now we see a wider range of prompts, like a bear next to a zebra, an epic tornado, horses joining a herd, origami dancers, and a robot in Times Square. Across these additional diverse scenarios, the videos using CFG-Zero generally look more aligned with the prompt and, well, just seem more consistent visually. Continuing with the video examples, Figure A4 here just gives us more of the same type of comparison we saw in the previous figures. Again, it's standard CFG on top and the CFG-Zero method labeled hours on the bottom using WAN 2.1. This time we see prompts like a cartoon character disco dancing, a cat waking its owner, and a happy dog wearing sunglasses on a beach. And, similar to the other examples, the CFG-Zero results generally appear a bit more consistent and maybe capture the details of the prompt more effectively. So, looking across all these examples, both images and the video sequences we just saw, it really seems like the CFG-Zero approach offers a more robust way to guide these flow matching models, leading to results that are often more coherent and better aligned with the prompts. And that's important because, well, better guidance means more reliable and controllable generative AI, which is obviously a huge area of focus right now. That's all the time we have for today. Thanks for tuning in to the AI Research Roundup. I'm your host, Alex.